Alex talked a lot about how LLMs were built to predict the next word. So people used a lot of data. They scraped it from the web, and all that the model was trained on was to predict the next word. So why is this a useful thing to do in practice? So it turns out that, as you probably already guessed, a lot of the things can actually be reframed as next word prediction tasks, right? So for example, consider this sentence here. Whoops. Consider the sentence here. So the sentence saying the plot was substandard, but it left a smile. And the next sentence goes, what is the sentiment of the above sentence? So if there was a model which was sufficiently trained on predicting what the next word is going to be, then you would expect that it ends up predicting the word positive, because you're trying to do some kind of sentiment analysis here. And usually it's a positive or a negative classification, right? So if you've kind of learned how to do this next word prediction task, it turns out that you can actually use it for a lot of different tasks. Most likely, any task that you're kind of thinking of can be framed as a next word prediction task. Maybe as an exercise, try to think of a task which cannot be framed as one, and then maybe we can chat after the workshop ends. But it's surprisingly effective. So for example, here summarization. So you can try to get it to look at a large amount of text and then try to convert it with just a few sentences. Or a sentiment analysis, as we saw it on the previous slide. Question answering can always be framed as an next word prediction, where it's like you give it the question and then ask it what do you think the answer is. And this is a really powerful concept, because around a couple years ago, what people started realizing was, okay, if you train this really general purpose large language model, we don't have to try and train very task specific models. We can try to use this and adapt these models in very simple ways to get a task specific model which can be used for, say, medical question answering, or for search engines and so on, right? So this is kind of the main framework you should keep in mind when we're looking at how we want to solve tasks using ChatGPT. So while next word prediction is a great way of using these large language models, there's an inherent problem when we're trying to interact with these models. For example, let's say I ask the question, who's the best footballer? Okay, I mean soccer player. And one answer could be, here ChatGPT goes on to say that it's a very subjective matter, but it also goes on to suggest a name, for example, Messi here, and it goes on to explain why he's considered as one of the best players. Whereas another completion that ChatGPT comes up with is, it says that there's no definitive answer and it's subjective, and it stops there. It doesn't say anything more, right? So now when you look at these two responses, they're technically correct for the question that I asked, because in one case it declines to answer, in the other case it says it's subjective but goes on to give me an answer. So from the perspective of the language model, both of these are correct completions, and the first one is arguably a little more informative because you walked away with some information. And this preference that you have for the first answer here is not really understood by the large language model. So talking about it in a little bit more detail, so let's just do a quick thought experiment, right? So let's say you have, you're trying to interact with ChatGPT, you're super lazy, so you don't want to write this email, and you ask ChatGPT, write a strongly worded email to my coworker about their unfinished task, right? So let's consider these two responses. The first one, the first one says, the task is of extreme importance and I wish you took its completion seriously. Whereas the second one says, you're a terrible colleague and you did not finish your assigned tasks. Technically, both of these are correct responses, but which one would you prefer? If you prefer the second one, just don't say it out loud, but most probably you prefer the first one. And even though both these completions are correct, we want to ensure that the output of this large language model is in some sense aligned to what humans prefer, right? So how do we encode this human preference into the language model? So I think someone asked the question earlier on how to use reinforcement learning. So that's what we'll kind of talk about now. So again, just to summarize, the high-level problem is there are multiple correct answers when you're doing this next word prediction. So how do we actually encode this human preference? So the way ChatGPT went about solving this issue is called reinforcement learning with human feedback. So what they do is, in the first step, they collect some demonstrations that were written by humans. So they gave these prompts to humans instead of ChatGPT, and they got multiple completions. And they used a model to learn how to complete in a way which is similar to the human completions. So you have this model. Now, in the second step, what they do is they learn a reward model where they give humans multiple completions for a given prompt, and they tell them to rank what they think is better. So for example, in the previous slide, the human would most likely say that the response which wasn't personally attacking your colleague was better than the one which attacked your colleague, right? So now you have this information. So what they do now is they learn a model which encodes this preference. So now, given a prompt and a completion, this model can tell which completion is preferred by humans more than the other. So now that you have this reward model, in the third step, they use this reward model down here. They use this reward model, RM, to predict a reward given a completion. And now this is powerful because now that you have this reward model, you can use ChatGPT to generate multiple completions, and then you can penalize the model every time it generates a completion which has a low reward, and you can incentivize whatever completion has a high reward. So in some sense, now you've used these human demonstrations and this reward model to teach ChatGPT what aligns better with human preferences and what misaligns with human preferences. If you had a data set where you somehow had this information about what completion is a good completion and what completion is a bad completion, then things would work out. But I just want to make sure everyone appreciates that it's a fundamental problem that when you scrape a lot of information from the web, there is going to be a lot of distasteful content out there, and unless you have an extremely good way of filtering what is quote unquote good data from bad data, it would be pretty hard to do that. But that being said, I think there's a paper yesterday, or I think very recently released, which does something similar to what you're saying, and they get decent performance. So it's called Anthropic, the organization which released the paper. So it works somewhat well, but I think it's a very circular problem because detecting if something is offensive or bad is as hard a problem as generating in some sense. You need to have a sophisticated model to do that in the first place. All right, so now let's go kind of to the capabilities of ChatGPT. I'm sure most of you have seen some lingering use cases on the web, on tweets, and so on. So this will be more like a summary, and hopefully you see something new as well. So the first thing is that you can use ChatGPT as a knowledge retriever. So this is the simplest use case. So these are things you'd probably Google. So who invented the telephone? And rather than going to Google, and Google also has these small tiles which show the answer now, but if you ask this to GPT-3 or ChatGPT, the answer will most likely be correct. Again, there are some factual inconsistencies sometimes, but it's most likely going to be correct. And it doesn't have to be only common things, for example, who's the first person to go to Mariana Trench? And I checked this yesterday and it gets it correct, right? Whatever it outputs. And one interesting thing is it's not necessary that all this factual information has to be in the same document. So for example, I'm guessing that the first and the second, the inventor of the telephone being Alexander Graham Bell, and the second piece of information, you'd most likely find a document which contains both these things, both the question and the answer. But something like what is bigger, an elephant or an iPhone, I doubt there's a single document which kind of has this. I mean, now maybe there's a single document which has this information, but to get this right, it needs to do some sort of multi-hop reasoning where it understands how big an elephant is, how big an iPhone is, and make some sort of comparison. So not only can it just retrieve knowledge from a single document, it can do some kind of complicated retrieval over multiple documents and so on. So this gets us into reasoning territory, right? So now we're not only talking about factual knowledge, we're also talking about can ChatGPT use these facts of knowledge to actually reason on top of that. So this was the example we saw on the previous slide, right? And at the same time, not only is it going to give you the answer, the way ChatGPT was trained was to explain the reasoning process so that you trust the answer a little bit more, right? So now, not only does it say an elephant is much bigger than an iPhone, it continues to reason why that is the case. So in this case, it says that, okay, an elephant is a large, like it's being very generous with the explanation, but it says, okay, elephant is a large land animal, blah, 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 it's 13 feet tall, and your iPhone is these many inches, so it's significantly larger. And like, I think the word significantly here also is of importance because it also realizes that 13 feet is like significantly larger than a few inches. It's able to reason and understand this. Next example is mathematical reasoning. So this is a simple word problem. It says, you can read the word problem, but it's a very simple word problem, trust me. And not only does it give the answer here, so 195 students, it kind of like goes ahead and like gives like a very exam style answer where it explains the reasoning process, assumes these kind of variables so that it's also easy to understand to humans. So this is where the reinforcement learning with human feedback actually shows its true colors, right? To answer this question, you don't really have to write it in this way. The reason it's written this way is because humans prefer getting their answers this way. They want to understand why an answer is a certain way. So this is easily consumable by humans rather than just telling what the answer is. So mathematical reasoning is something ChatGPT is not necessarily amazing at. This was an extremely simple example. It's a simple multiplication and division, so it gets it right. But it's not necessary it gets integration correct. So it does get it correct on in some instances, but this is something researchers are actively working on, trying to push the boundary in mathematical reasoning. The next example is reasoning about humor, because humor is has typically been a long-standing task where people have been like, oh, these machines can do these like trivial things, but humor is something more creative. It's you need like a higher level understanding and so on. So here, this is just a like pun, I guess. So how does an octopus go into a battle? Well armed, right? So it needs to understand that well armed means having arms, and at the same time the fact that octopus has like 8 arms. So that's the kind of like pun here, and it's able to explain why this is the case. So I think this kind of use case came about like a year ago, and like a lot of people were surprised that it's able to do this because, again, it's not trained specifically to understand jokes or understand any of these things. So this is just kind of an emergent ability of training ChatGPT on a large amount of data, because it's probably seen jokes somewhere. It's probably seen explanations somewhere. So even when you give it a new joke it hasn't seen before, it has the elements to kind of understand that, oh, humans find this funny, so this is probably what's going on. So this is hypothetical reasoning. Again, this is just interesting because now there's not, I doubt anyone's ever like mentioned this on the internet, right? So if a unicorn existed, how would it be as a pet? So it goes on to kind of talk about how they're like free-spirited, they need like intellectual stimulation, just based on the character understanding that it has of unicorn. So we've created a hypothetical situation here for ChatGPT because unicorns don't in fact exist, but that's the new reality, and like you need to reason kind of on top of that. So this is another interesting use case of how it lets us like have this, like it's like, okay, I'm going to assume that unicorns exist and go on. So cool. So that is reasoning. Now, I think a lot of people, at least a lot of non-researchers or like school students, the one they're most excited about, or the one that they're most exploiting at least, is using ChatGPT for quote-unquote creative tasks where you need to do this long-form generation, like multiple paragraphs, potentially sentences. For example, maybe you want to write an essay or an email. Maybe you want to summarize a certain website, so you don't have to read like 5 paragraphs. You can only read one of them, and so on, right? So some examples of how you can use ChatGPT for that, right? So this is an example of creative writing, like essays. This is like the most common one you've probably seen floating around. So here's a short essay for space exploration beyond the solar system. And like reading it kind of like gets the gist. It's like you can also change the tone of the essay. You can ask it to be more ambitious, you can ask it to be more conservative and so on, and it gets those cues and it's able to produce these essays. Met a high schooler recently, and they were like, they use ChatGPT to write these essays, and they run it through like a paraphrase tool, and then they submit it. Like at some point, all these universities are going to have like honor code policies where you don't use ChatGPT and so on, but this is one example of how you can use it to write essays. This is an example of me writing an email to my advisor that I'm not going to be working now and I'm going to be teaching a workshop instead. And it does a pretty good job. You just need to make like small modifications and it's able to get most of the gist across. And this is my favorite one, at least. So like creating itineraries. So like you're going somewhere, instead of going over like multiple websites, you tell it to kind of summarize what you want to do in like a few days. And it's interesting because like I've done this multiple times, and it doesn't necessarily retrieve things only from a single website. It can, like, I've done some amount of fact checking. It gets it right a decent number of times, but it's always good to fact check what ChatGPT says. And it's able to summarize things from multiple websites, and you can cater it to yourself. Like for example, here I say I like doing multiple things in a day, but you can also say I like doing outdoor activities. So it's able to pick and choose from different websites and give you a certain list that you can do. Any questions here? All right, cool. This is now more productivity-oriented use case. So this is again an emergent ability. Like, so Alex was showing you the data set. Luckily, ChatGPT is also trained on a lot of GitHub repositories, right? So now it turns out that programming languages are actually easier than natural languages because there's a certain structure to them. There's a concept of a context-free grammar and so on, right? So if you can do natural language processing, you would guess that, oh, you can do programming languages as well. So in this case, I asked it to write a NumPy code for finding pairwise distances between, or Euclidean distances between n vectors. And it's not a complicated prompt, but it's complicated enough that if I gave it to an undergrad at Princeton, they would take maybe 20 minutes to figure this out, right? And yeah, this is the answer. And like, recently I was teaching at a workshop where we had like a code component in the afternoon, and I made the mistake of showing this in the morning, and like everyone's like finishing assignments in like 30 minutes and so on. But it's surprisingly good. So there's also a tool called Copilot, which is part of GitHub, which uses similar language models. Not ChatGPT, but uses similar language models, and it's extremely good at code completion. So if any of you actually code daily or like often enough, I'd kind of like encourage you to like take a look at it. It improves productivity by quite a bit. So I think Alex and I use it as well. So another example is LaTeX. Again, LaTeX is just another kind of, it's a combination of natural language and programming language. So here I'm asking, can you generate LaTeX code for creating a fully connected graph with 5 nodes? And this was what it outputted. There's no way to verify, but yeah, I put it in overleaf, and this is a reasonable starting point, and you can make modifications on top of this. Life becomes easier. So definitely, I think code is, ChatGPT for code is an evolving use case. It gets a decent amount of code right, but like with code, small changes, like one word changes often lead to an incorrect program. So again, a lot of people are working on this, trying to make sure the accuracy is really high. I'm sure over the next 1 year, like the systems are going to keep improving. But it's always good to verify what ChatGPT outputs. So far we've talked about this single turn way of interacting with ChatGPT, right? So we ask it a question, it gives an answer. We ask it to perform a task, it performs a task. But how do we go about incorporating dialogue? So a key component of dialogue is you need to maintain context of what was said before, right? So when I'm speaking now, I'm already assuming that you guys remember what Alex taught you. So I have that context that I can base my sentences on. So let's say I ask it, can you provide a short list of prominent people from India? And it goes on to give me this list. And both these, so Mahatma Gandhi and Jawaharlal Nehru, both are political leaders. So in my next turn, what I tell it is, can you exclude politicians? So this prompt in itself doesn't make sense, right? So if I just ask ChatGPT, can you exclude politicians? It probably will go ahead and give me some list of people who are not necessarily Indians, right? So it needs to understand that, okay, I asked prominent people, India, and I'm saying exclude politicians. And it's able to use that context and now produce this output where one is a sports person and another is a business person. So ChatGPT is able to maintain this history, and you can actually, when you're interacting with ChatGPT, there's a certain number of turns you can go, like significantly greater than one, but it allows you to interact in a way that you iteratively modify your answer. For example, let's say you ask, you tell it to write an email to your advisor, and like you realize that it's a little too formal because like no one maybe says like dear professor every single time you talk to your advisor, and you tell it, can you make it a little more informal, and like it's able to look at that response and iteratively refine it and give you a better response. So another example is I'm asking how many states are in South India, and it produces this list. And then I ask it, what's the capital of the second state you mentioned? So it's able to realize that, okay, the second state is here, and it looks for the capital of that state. And interestingly, while this seems like an extremely different way of interacting with the model with respect to what we saw before, with respect to how OpenAI did it, it's extremely simple. So what all they do is initially they were taking this as the context and producing this as the output. Now, when you ask it another question, they just assume the whole thing is the context. So instead of feeding just one question and then answering, they take this whole 3 chunks as the input, and they can produce the output now. So from an engineering perspective, or like from a methodological perspective, it's just a change of how many chunks you're using as part of your input. So the next thing I kind of wanted to talk about, and this is extremely important if you were trying to use ChatGPT for your research, is ChatGPT only using prior knowledge to understand things? Or can you actually teach it novel tasks, right? So if it's only using prior knowledge, it's possible that a new task that you came up with today, or potentially even the one you come up with tomorrow, ChatGPT is not able to solve. So let's look at an example. So here I give it an input. I say input 1, output 1. Input 2, output 1, 2. And then I say input 3. And you've probably seen the pattern here. It's 1, 1, 2. So it's probably this as the answer and gets it correct. So now it's hard for me to convey how I want this output in words. So it's easier for me to give what are called demonstrations. So here I just say that given this is the input, this is what the output looks like. Given a different input, this is what the output looks like. And what ChatGPT is able to do is look at these demonstrations and figure out exactly what the task is. So in some sense, you've used these demonstrations to define what ChatGPT's output should be. So as another example, here I say there's an article about Joe Biden, and I say the output is A. And like here, A could be anything. We don't know what it is, but I told the model to choose between A and B, and it chose. I told that A is the answer for this. And for the second input, I say the third game of the finals commenced today, and I said it was B. So any guesses of what A and B are? Hopefully some of you have kind of realized that A should kind of be politics, B should probably be sports, right? It's the topic of the sentence. But ChatGPT actually doesn't know what A and B are, the same way you guys were slightly confused what A and B are. And now, let's say I give it an input about the recent halftime show. It's able to extrapolate that, oh, B is probably sports, so the answer should be B. So now, this is powerful because let's say your research is in biology, and like there's some disease classification that you're performing, and it's either in, say, a new disease or a very niche disease which is not seen on the web, or there's very little data. What you can do is, if ChatGPT is not able to answer your question correctly, you can collect these small like you can collect these small number of demonstrations. Often just 1 to 5 will do a pretty good job. And these 5 demonstrations will kind of teach ChatGPT, okay, what you're looking for. And it's able to build off of the knowledge it already has and then answer the question that you give it. So this is a way to kind of define a task using demonstrations instead of using instructions. So this is called in-context learning because the model is learning what the task is by what you provide in context.